Okay, so finally in this lecture, let me just summarise what we've learned. I want to make really 5 points. First, we've learned that the choice of regression model depends not only on the distribution of the response, which was the message of our previous lecture on GLMs, but also on the structure of the data. We've looked at longitudinal and cluster data and said that these kinds of data, in which there's some natural grouping or some natural partition, we need to account for potential dependency between observations. Second point, in the lecture, I've introduced the linear mix model as an extension of the classical linear model and shown that it can incorporate both fixed effects and random effects. And this allows us to model between subject and within subject variability. Third point, we discussed interpretation of the linear mix model of fixed effects, of random intercepts and random slopes, and we also talked about the covariance structure that's induced by the inclusion of the random effects themselves. In addition, we talked about two complementary ways of interpreting the model, the population interpretation and the subject-specific interpretation. The fourth point, I then talked about estimation. We introduced maximum likelihood and maximum and restricted maximum likelihood estimation as the method to estimate mixed models. We explained why REML is preferred for variance components and demonstrated linear mixed model estimation in R using the data on the height of boys from Oxford. And finally, I briefly introduced the generalized linear mixed model as a natural extension of GLMs that combines their distributional flexibility with the dependence modeling provided by mixed models. And I introduced or used the mixed model as a leading example of a GLLM that's used a lot in transport engineering. So that is all for lecture 8.